So for our first one up here where we're factoring it, you'll notice that it's a quadratic. So if I can factor it, it's going to be x in the parentheses and x in the parentheses. We're breaking it up into those two. Now, if this actually works, we can find two numbers that add to 15 and multiply to 56. Is there such a pair of numbers?
Yes.
Yes, there is. What are those two numbers that add to 15 and multiply to 56? Yep, it is 8 and 7, so you write it as x plus 8 and x plus 7. All right. Next one. Let's go over from there. You'll notice that in this case there's something I can divide every term by. So I'm going to do that first. So since I can divide every term by 5, I'm going to start there. So we're going to do 5 parentheses x cubed plus 3x plus 10. Then the question is, can we factor it further from there? Well, notice that this one is an x cubed, not an x squared. Because of that, it does not actually go any further than that, so that one is done. That's all you can do, is just factor the 5 out of every term. Right, next one. The x cubed plus 13x squared plus x. It looks like there is something we can divide out of every term here. What is in every term? Yep, x. And so, I'm going to pull x out of every term here. So that's going to give me x squared plus 13x. And remember the plus 1. Oftentimes we forget about the plus 1 hanging on the end. But if you do, that's going to cause all sorts of problems. Of course, they'll be incorrect, but it also can lead to other issues, and like what we're going to be doing later today. All right, so from here, I notice that it is a quadratic, so it is x squared in there. So, does this factor further? Well, really, that's a question of, are there two numbers that add to 13 and multiply to 1? Well, the only way we can multiply to 1 is 1 times 1. 1 plus 1, not 13. So, that one's it. That's done. We can't factor it any further than that. All right, next up here, our 12x to the 7th one. Again, we want to start by looking to see what we can divide out of every single term. If I look at the numbers, the 12, the 16, the 36, what can I divide all of those by? 2 works, but there is something bigger. 4, yeah. I can pull a 4 out. Can I pull any x's out? Yep. We can pull out that x cubed there, so we can pull out 3x's. So we're going to pull out 4x cubed. And so when we do that then, that leaves us with 3x to the 4th plus 4x, and then plus 9, and just 9. Does that factor any further past that? No. And so that's as good as that gets. All right. Now that's the top half done. We're going to be doing the same kind of process on the bottom half, but we're going to be seeing that things get a little bit more interesting looking. So the top half, as you take a look at this set of problems, the top half of problems here, all of these were kind of old factoring that we've done plenty of in the past and should all have been reviewed. The bottom theoretically is as well, but I'm making some of it look a little bit different because we need to be able to move fluidly into some of these other terms, some of these other ways of looking at it. But it is still the same ideas. So like as I take a look at this 13xy plus 9y, I can still start by asking what I can divide out of every single term. So what can we pull out of every term there? Yeah, we could pull out y. And so I factor the y out of both of those terms. And that just leaves us with the 13x and the 9 on the inside. All right, going over from there, I now see that both of those terms again include something that's the same, right? Notice here we have this g parentheses x. Now, first of all, does that mean g times x? No. Remember, when we see the letter and then the parentheses with the letter inside, this is telling us function notation. So really this does not mean g times x, this is g of x. But I still see that it's multiplied into both of the terms, which means I could then also factor that out. So I'm going to take that g of x and I'm going to factor it outside, and then whatever's left, that's what's going to be left inside the parentheses. And so we end up with g of x times 13x plus 9. And the cool thing about this particular one is that g of x truly can be anything. G of x is just some function. It's just something we don't even know yet. But it can be anything we want it to be, which shows that you can actually factor anything out, including whole functions, out of these, which is kind of what we're going to be doing today. And just to kind of bring the idea home, yes, there's smiley faces in this expression. But still, what can I pull out of every term? Yeah. It all works the same way. Anything that is in every single term can be factored out of every single term. And so with that idea in mind, take a look at this last one. So, in this last problem, what do you see in every term? Notice the 4x plus 7 shows up both times. And so I can actually factor this 4x plus 7 out of both of those terms, and when I do so, I'm going to be left with whatever is not the 4x plus 7. And so I'm going to be left with the 3x plus 9 once again. And so notice, all of these are that 13x plus 9. It's just a matter of exactly what is it that we're factoring out of both of the terms. But it's the same idea for all of them. So you can factor even binomials out of these. And that's going to be part of what we do in today's new process. Because today is going to be all about factoring, but we're taking our level of factoring and our abilities with graphing up a notch today. We're going to be able to factor some stuff that we wouldn't have been able to before. But we're doing some prep work to get there. Particularly because problems like this are going to be showing up in this new process. And you're going to have to be factoring with stuff that looks like that. So, to help reinforce, I want to do a few more problems that end up looking like that. So, please write down and factor each of these three, and then we'll make sure that we can handle those, and then we'll do a little bit more practice. All right, so like on this first one, we look to see what we can factor out of each term, and you see it's the 6x plus 1, but I want to point something out here as we do this. As I pull out that 6x plus 1, I then have the 32x minus 17 left. Parentheses do matter as you do these. So I'm seeing a couple different things crop up. I'm seeing some people who might write it like that. But if we did this, what is actually multiplying into the parentheses? The 1, and only the 1. But you'll notice that both of these, the 32x and the 17, are both being multiplied by the 6x plus 1. And therefore we do need parentheses around both of them. Having both of those sets of parentheses is essential because we have that addition and subtraction on the inside. It makes a big difference into what it means. All right, then for the next one, we have the 8x minus 5 that appears in both terms. So I'm going to factor that outside, and notice what's left. We're left with the 3x, and we're left with the 10. So 8x minus 5 times the 3x plus 10. And now this last one can sometimes be a little bit tricky, because in some ways it's very different. Because if we look at it strictly as the number of terms that we have here, we'd actually be saying there's like 3 terms there, which would then mean there's nothing we could divide out of all 3 terms. But you also probably notice here that there is a 7x minus 11 appearing twice. But in order to be able to pull out that 7x minus 11, I need to know what would be left behind in this last term if I pulled it out. Well, let's say I want to put parentheses around that 7x minus 11. What would I write out front of those parentheses?
1.
Yep, 1. And so once I can see that that's the same thing, now I can go ahead and factor that out. And so now I can see why I would get the 7x minus 11 times 9x plus 1. There. All right, now each of these, this is actually going to be the last step of a process that we're going to be doing as our big concept for the day. But I'm going to go through one last layer of prepping you for that new concept, just to help us remember how we're doing. Because that big concept that we're doing is factoring quadratics, but they're going to be tougher to work with. So let's practice and remember how we go the other direction, where we expand out our quadratics. So we're going to write down and expand both of these. So please write down that first one, and then I'm going to show you what we're doing with it, even though I think you already know, but I'm going to show you in a slightly different way to help kind of reinforce an idea. So if I'm going to be multiplying this through, of course we know that I'm going to be multiplying everything in the first parentheses by everything in the second parentheses, right? Do you understand why that works? And why we have to multiply everything in the first by everything in the second? Well, let's take a look here. Notice the first thing I'm doing is I'm multiplying that x from the first parentheses by both the x and the minus 6. Really, what I'm doing is I'm multiplying x times x minus 6, and I'm distributing it in there. That's why it has to go to both. And the 10 also distributes to both. So the 10 is being multiplied also by x minus 6. And since there's a positive 10, like there's a plus between them. This is why we multiply everything in the first by everything in the second. It's basically just distributive property, which you see done there, and then using distributive property on the result. And so once I've gotten to that point, I can go ahead and multiply it through. And of course, we combine the like terms, right? And so, yes, we get x squared plus 4x minus 60. But now, repeat the process for that second one. Please multiply this one out as well. But again, actually write it out this way first. There is reason for why we want to be writing it out that way, as you'll see soon. And so in this case, we're multiplying the 8x by both the 3x and the minus 11. And so that gives us that part. And then we're also multiplying that negative 5 through. So the negative 5 multiplies by both the 3x and the negative 11 as well. Then once you've done that, then go ahead and multiply it through. And yes, I know most of you will be very comfortable just jumping straight from the original problem into this line, because you are very comfortable with the whole multiply everything in the first by everything in the second kind of an idea. But we wanted to kind of remind ourselves why it works, especially because what we're going to be doing today is we're actually going to be starting with something that looks like this. We're going to be starting with a quadratic, but in this case, the quadratics that we're going to be starting with are no longer just going to be a plain old x squared. There's going to be a number in front of the x squared that we're going to have to deal with. It doesn't just factor out. Like you'll notice, I cannot divide everything there by 24. And so if we're going to factor these, what you're going to find is that our work is going to look exactly like this, except in reverse. So we are going to start with a line that looks like this. That'll be the original problem. We will then split up our middle number, our x term, into two other numbers, so it's going to look like that, and we'll talk about how we know what those two numbers are. And then once we have that, we're going to factor and then factor. And that's the process that we're about to go through. So let's take a look at how we would actually execute that process. Please write down this problem, and then I'm going to walk you through step by step all the work we do to be able to factor it. And as we do so, the method that I'm going to be talking you through today and teaching you is called the grouping method. This grouping method is basically one of two different methods, as far as I can think of at least, that is used to factor quadratics. The other one is guess and check. Now, after doing a bunch of grouping method problems, you might find yourself using guess and check for some of them. And that's okay. If your instincts tell you what the solution is, like what the factor form looks like without having to do a bunch of extra work, that's fine. But I like teaching you the grouping method because if you know grouping, you have a way to factor anything even if you can't guess your way through it. So it always gives you something that's going to work. All right. So then, how do we do it? The very first step is to multiply our A and C values. And so you want to write this down as your work and also include the steps that we're doing off to the side, as these will be rotating through as we go. When I talk about multiplying A and C, A is just that same number in front of x squared. Like remember last week we were talking about finding the vertex with negative b over 2a? We're talking about the same A's, B's, and C's. And so C is that last term. And so what you can see here that I did 88 for my A term, and I multiplied that by the negative 108, which was C. And that gave me this big old number, negative 9,504. It's a big number, and we're going to have to wrestle with that big number as we go. One little side note before we go too deep into it, just so I don't forget about it. This is actually just a souped up version of the same method that you've been using, where we did have no number in front of the x squared. Like if it was just plain old x squared, we'd say what adds to the middle number and multiply to the last number. The reason why that worked is because in those situations, your A value was 1. And so A times C gave you whatever C was. It didn't change it. And you're going to see today that this actually could be used the same way. It just would be a little bit trickier to go through the steps this way. All right, so now that I figured out what AC is, I now want to find two numbers that add to B and multiply to AC. So again, add to and multiply to. Just instead of adding to the middle number and multiplying to the last number, it's adding to the middle number, 3, and multiplying to AC, the negative 9,504. So that means we now need to look into figuring out what is that combination of numbers. Some recent problems you were seeing on WAMAC are like this, right? You've been asked what adds to this, multiplies to that, but they've been bigger numbers. It's getting you ready for being able to deal with this stuff. Okay? Now, in this case, I'm not going to have you have to go and do all the work yourself to find this combination. I'll tell you what it is here in a moment. And I say that partly because it could take a long while without some other strategies. Next week, we'll also talk about some different strategies that allow us to find these numbers a little bit faster. Like with some strategies that we'll talk about next week, you would only have to try like 3 different numbers and you'd be able to find the solution in this case. But we aren't there yet. We don't need to add an extra layer of complexity. So for now, I will go ahead and tell you that if you took that 9,504 and did divide by 1, and look to see if that added to 3, and then divide by 2, and then look to see if that added to 3, and by 3, and by 4. You'll be doing that for a long while, because the actual combination of numbers that adds to 3 and multiplies to negative 9,504 is negative 96 and 99. That's the combination that adds to and multiplies to. So write that down, and note that that's what adds to 3 and multiplies to negative 9504. So you remember where those came from. All right, now that we've found our two numbers, that is actually the part that's going to take you the most time in doing these types of problems. The rest of it from here is a process that you're going to be learning, so you're going to find that the steps we go to next are going to be the ones that feel weirdest at first because they're unfamiliar. But very quickly, I would expect you to be able to find that finding the add to multiply to combo will be the actual tough part, because then you'll know the process from there. All right, so once I find those two numbers, remember that these two numbers that we just found, they add to 3, right? And so what I'm going to do is I am now going to actually break up my 3x into 2 parts. I'm going to break my 3x up into a negative 96x and a 99x. And so then this is what my equation looks like, where I take my 3x and I break it up into the two numbers that I found. The ones that added to the middle number and added and multiplied to AC. All right, so all we've done up to this point is we've split that 3x into 2 parts. But this is actually what we needed, because my next step is going to be to take a look at these first 2 terms, and I'm going to factor what I can out of those first 2 terms. And then I'm going to take a look at the last 2 terms, and I'm going to factor what I can out of those last 2 terms. So let's go ahead and do that now. For those first 2 terms, 88x squared minus 96x. What can I divide both of those terms by? Yep. We can factor 8 out of both the 88 and the 96, and since both terms include x, we can make that an 8x. Don't forget the x's as you're doing these. That's one of the common errors that can creep up on these. Because if you do start forgetting the x's, then it won't make any sense. All right, so when I do that then, that gives me 11x minus 12 on the inside there. Now remember, all I did there was I just factored those first two terms. Now I'm going to repeat the process on the second two terms. So looking at the 99x and the 108. What can I divide both of those by? 9. Can I factor an x out of both? Nope. And so since I'm going to be factoring out a 9, I do write the plus in front of the 9 because I'm adding this second half. So if I divide that out of each term, I end up with 11x minus 12. What do you notice about what we just wrote there? Notice this looks a lot like those problems that we were practicing factoring at the start. And you'll notice what we have here inside the parentheses, 11x minus 12 and 11x minus 12. The fact that those 11x minus 12s were the same is what tells me that I've done this right. If they weren't the same, that'd be a red flag to me, telling me I need to go check something because something went off. So, again, add this information now to your notes, and then we will finish this off in our next step. All right, and we just have one last step here. Our last step is to finish factoring it. And so since this looks like those problems we had earlier, we're going to do the same thing we did earlier. So what can I factor out of both terms? 11x minus 12, right? So I factored the 11x minus 12 out of both terms. Now you notice I wrote it second here. Why did I write it second? Arbitrary choice. The order in which we write these parentheses does not matter. It does not change anything. And so then whatever is left behind, the 8x and the plus 9, that's what's then in our other set of parentheses. That is our factored form. So notice we were then able to factor something that we couldn't have otherwise before, because this 88 changed everything. If I just said what adds to the middle number and multiply to the last number, you actually would have come up with, in this case, a negative 9 and a positive 12, which actually looks pretty close to what we had. That's more coincidence than anything. But we would not have come up with the 8 and the 11 that way. All right, and then one last little side note here. Remember when I said what adds to this and multiplies to this? I ended up with the negative 96 and the positive 99. I wrote them in that order. Note that if I had written them in the other order, I still would have ended up with the same answer. The only difference is that if I had written it in this order instead, this line would have looked different. It would have instead been 11x, oops, don't need a parenthesis there, would have been 11x and then 8x plus 9, and then minus 12, 8x plus 9. Which, notice, would still factor to give us the exact same thing here. So you will end up with the same answer either way. It's just a matter of what that one little intermediate step looks like in getting there.